Good morning, everybody. This is a live extreme weather briefing. High plains insanity is definitely happening. And this is a look at a tornado yesterday that was a damaging tornado intercepted by Mark. He is on the board. Actually saw 3 tornadoes yesterday. And here is a look at that supercell storm that fired off to the west of this area, off the foothills, and that really matured near Bergen, Alberta. Quite a bit of damage was caused just to the northeast of Bergen as well. You can see a classic hook-like appendage with that storm. And inside of that hook, you can even see the radar wrap on the radar here that this is to the southwest of the Red Deer area. That was our target area. There you can see Mark's look at the rope out of that tornado. I believe it classified that as a separate tornado from the one that caused some damage just to the northeast of Bergen and actually intercepted 3 tornadoes during this day. You can see the occlusion back behind. Look at that occluded tornado vortex roping out and also going a little bit southward. So I think what you're seeing here is that part of the tornado where it actually turned to the south. And Mark did a very detailed drone damage survey. Usually when tornadoes mature, they do a left-hand turn as they rope out. This one, though, went off to the south, and I think you could see this curving over the cold pool, kind of a cold, dense area of air sliding from north to south underneath it. It helps to bulge out the vortex a little bit, causes it to stretch, causes it to rope out as well. So sometimes you get these tornadoes that show deviant motion that move off to the south, and I'm going to show you that damage path that Mark analyzed. First, I want to show you the damage. There's the radar that you can see that is near Bergen area. And this drone footage is from Mark. Here you can see his entire drone survey. We'll call this the Dominator drone as well. You can see a lot of these softwood trees that were absolutely flattened out here. He also did a damage survey and showed the path. Usually when you get these trees that are snapped off like this over a wide area, it's pretty hard not to rate that an EF2 tornado. Also some pretty substantial structural damage out there. A farmstead sustained some substantial damage. This is Mark's look at the damage path yesterday from the drone. And here is his estimated, based on that drone survey. And this is not official. This is Mark's very detailed damage survey. He does a great job on these damage surveys. He sampled EF0 damage early on in its path, moving off to the northeast. And then a lot of times as these tornadoes mature, they'll usually do a left-hand turn as the vortex is shed off to the north. This one, though, did a southward turn. The tornado was just cruising at about 10 miles an hour off to the northeast, causing relatively less damage. And then suddenly, as it was roping out, it did this southward turn. And I believe that this is as the rear flank downdraft, which was coming out of the north, undercut the tornado vortex. Usually cold, more dense air will slide underneath the warmer air just above it. And as that rear flank downdraft was sliding around the backside of the tornado, it caused the tornado vortex to bulge out and stretch just a little bit. And I think that we actually see that in Mark's video. And he also had a video of the tornado being so obscured as well at maturity. It was a very large cone tornado, and then suddenly it got obscured in some rain and some hail. But incredibly, that southward turn that this tornado did was certainly due to the rope out that happened, and you can see this in Mark's video. I believe that at this location is when that rope out happened. See how the cold air is sliding in underneath the warmer air, causing the tornado vortex to bulge out a little bit like that. You can almost see the shape of the cold pool, and this caused the tornado vortex to move from north to south. I believe that this tornado coned, it was a pretty large cone, and then the rain encapsulated the tornado vortex completely, losing visual of that tornado. And then this rope popped out of the rain just as it was about to do that north to south moving turn. And it was a very sharp, dramatic turn upon this rope out, and that was as the northerly flow was coming in back behind the storm, undercutting that tornado vortex at maturity. And I want to show you now, hang on here everybody, I'm going to show you what the tornado looked like at maturity. This is also from Mark, Chase and Spin. I was going to fly up there and intercept this event with Mark, but boy is it a good thing that I didn't, because I looked last night at my passport, and actually my passport suddenly is expired. I thought it expired during September of 2022, but it was actually September of 2021, so I probably would have been stuck at the border, definitely. So here you can see the tornado near maturity, and look at all that rain that is concealing the tornado from view at this time. Just a classic rain-wrapped occlusion right at the bulge of the hook. You can see this new wall cloud here just in front of the rain, but the actual tornado is back in here embedded with that rain. And Mark showed the cone get encapsulated by this rain wrap. You can see the rain sheath that is way out like that, wrapping completely around the tornado vortex. This was as it was moving off to the east-northeast. And then as the occlusion process continued to commence, you had the rear flank downdraft, a northerly surge in the backside of the storm that caused the roping out tornado when it became more visible to show that type of a shape wrapping around the cold pool. But at this time, the tornado was at maturity and wrapped in rain. And here you can see the radar image at about this time, and you can actually see the rain wrap. Check this out in the radar reflectivity. That's just there. You can see Bergen. And right there, you can even see a donut hole. Look at that bounded weak echo region right in the middle. You can see the high reflectivity of that very heavy rain and hail wrapping all the way around that tornado cyclone, even a new cycle just to the northeast of it. This is the forward flank gust front. The tighter that gradient, the stronger the inflow into the storm, the more mature the supercell. The more inflow dominant is that supercell. This is the forward flank downdraft portion of the storm. Rear flank downdraft happens right behind it. That's where you get the sinking air that wraps around the backside of the mesocyclone. Will also surge out to the south side, bulging out a bit. And just like the elbow region of a derecho, you get the generation of cyclonic vorticity right off that RFD bulge that rides the gap between the forward flank gust front and the bulging RFD, rides it all the way in there, and then you get an occlusion process. By definition, the tornado vortex occurs at a smaller scale than the mesocyclone because of that clear slot that cuts in the backside of the mesocyclone and wraps completely around it. So there is the tornado at maturity. You can actually see that rain wrap that's happening in there. This is the rain wrap sheath, the donut that's wrapping around. Inside of here, inside the updraft, you get the bounded weak echo region, and that goes almost all the way up to probably 10, 15,000 feet or so before you transition to that tilted mesocyclonic flow that we sampled with our rocket launch in 2019 during the Linwood tornado. You could definitely see the new wall cloud forming here, and it's a little bit in front of the rain, just a little bit in front of this occluded tornado cyclone, which is in there somewhere. It's hard to see because of the very intense rain wrap. Here you can see your RFD gust front bulging out in front of that tornado. You can almost see the notch right there too. Look at that notch. That's the notch between the forward flank gust front and this bulging RFD. So you can almost see where the wind is going right up into that notch. And you're starting to get the formation of a new wall cloud. It's not yet occluded when it shows as a wall cloud, but then once that RFD continues to bulge and wraps all the way around that circulation, once the occlusion process is complete, then your tornado vortex starts to dynamically pipe down to the surface, and that's when you get a new tornado. And I do believe that Mark saw a bunch of tornadoes, 3 in total, as he was out there chasing those storms. Thank you, Facebook, as well. I'm having some issues with my algorithm throttling all of my content. So every single time I've been going live recently, I've been getting these automated copyright violations that are matching up to the windshield wipers, and it's all artificial intelligence. You can't get in contact with a real person out there, but I've got like 35 of these claims from like TNT Sports Chile, all these other organizations, and it is throttling our reach big time. That's why notifications aren't going out, all kinds of major issues right now with Facebook. So if you can hit that share button, it would definitely help us out a lot on Facebook to kind of overcome some of these issues. I mean, we might even lose our channel altogether at this rate if we don't take control of this, definitely. But I can't even get a hold of a real person, definitely to get support. It's been a major challenge so far, but that's just life as well. You know, you just got to navigate some of these challenges. Kind of being a pure scrapper like this is usually associated with things that happen like this. We're kind of at the forefront of all the technology with this live streaming. So here's the upper level pattern. Let's pivot from yesterday to today. And in general, we've got this semi-permanent trough that's off the Pacific Northwest. And this is what's leading to the massive moisture across this area and abundance of precipitation. We had that record-breaking flood event down near Yellowstone. We also had big-time flooding off the Bow River to the west of Calgary. And it's all because of this semi-permanent low off the Pacific Northwest, which is all due to the NPO, or the North Pacific Oscillation in the North Pacific. That helps to maintain that semi-permanent trough up there. And then you also have this large-scale ridge that is starting to migrate back to the Four Corners region. That could signify the reemergence of monsoon. I was looking at some of the long-range forecasts. It does look a little bit dry in Arizona, but we definitely need to keep an eye on that. But this trough off the Pacific Northwest is maintained, and we just have this broad southwesterly flow across the Canadian high prairies and across Saskatchewan. I think there's probably going to be more tornadoes across this portion of Saskatchewan today, ahead of the same wave that created the tornado yesterday across the high plains of Alberta. For some reason, Montana doesn't get as prolific of a high plains tornado season, and I think it's because of the geographic complexities out there. The mountains bend way to the west. You have some of these isolated mountain ranges as well off to the east, but you do get quite a few high plains tornadoes across Wyoming into western South Dakota, of course Colorado, down into eastern New Mexico, western Texas, even earlier in the season, down in the high plains of Mexico, down there west of Eagle Pass. You'll even get quite a bit of precipitation out there as well. Let's see if I can, there we go. Just had to get rid of that new awesome feature that Brian has added about adding subscriptions up there. We also have this semi-permanent trough over eastern Canada, and that's led to some bulk shear that will occasionally make it down to the southeastern US. You also have these disturbances that are rotating through, basically more like MCVs, Ridge Rider events that could lead to an uptick in severe weather today across southern Indiana, southern Illinois, central and western Kentucky. And also those complexes of storms will migrate off to the southeast, flash flood potential, big rain and windbags. We went up to West Virginia just a couple of days ago to chase down that flash flood potential. That's all the ring of fire, all these disturbances that continue to go around that high pressure. This is the ridge down here, an anticyclone that is centered very close to the Four Corners region, and you just keep getting these disturbances rotating over top that ridge in a clockwise direction. So this is the 12Z model. We'll go toward peak heating today. And look at this trough eject downstream across western Saskatchewan. You even get some reinvigorated flow across western Montana. Could be a couple of tornadoes across north central Montana later on today. But I do think that this threat across western Saskatchewan is the most favorable for tornadoes. But look at this reinvigoration of the MCV, kind of a jet streak that's coupled with that mesoscale convective vortex. This could lead, definitely is going to lead to an uptick in severe weather as well across southern Indiana and western Kentucky. But very generally, we could look at the 0 to 3 kilometer EHI to see where instability is matched up with wind shear, the lowest 3 kilometers. And you definitely have this arc into central Saskatchewan, wrap it all the way down to the Regina area. Sean and Melville, Dominator 3 is going to have to keep an eye on this. Also have a stripe of storms. Usually the western gradient of these will end up producing maybe even northwestern Montana, possibly central Idaho could get in on the action as well. Probably some flash flooding up in those zones. And you can also see the bright colors down here with the 0 to 3 EHI across northern Kentucky. You can look at a quick forecast sounding across northern Kentucky. First glance, the hodograph does look quite favorable. Definitely looks supportive of tornadoes. Let me expand up a little bit so that you can see the low-level thermodynamics. You can definitely see quite a bit of directional shear as well. This is over north central Kentucky, and this hodograph is quite favorable for wind shear. It shows the abundance of directional shear at the low levels. It even shows a little bit of a southwesterly low-level jet just ahead of the MCV. And then you head over to the northwest flow in the mid-levels of the atmosphere. As is often the case with these Ridge Rider and MCV setups, you do have a very saturated profile all the way up. Not very much of a dry slot in the mid-levels of the atmosphere to steepen those lapse rates. But I wouldn't be surprised to see a tornado or two ahead of this MCV. A couple of days ago when I was chasing in West Virginia, That tornado near Goshen, Ohio, just to the east of Cincinnati, was given an EF2 rating. So that was a pretty substantial tornado event just to the east of Cincinnati that happened, and that was the same complex of storms that rode all the way into West Virginia. We eventually intercepted that by drone in West Virginia, including the flash flood that it caused to the south of Charleston. This is a very similar event to that, and I wouldn't be surprised to see a couple isolated tornado reports across northern Kentucky, southern Indiana with that one. The next target would also be up here into central Saskatchewan, east of Saskatoon, well northwest of Melville. That's where I'd be targeting for the Saskatchewan tornado threat. We also got to watch this high plains area, though, down into Montana. And I was thinking about targeting the very next day as well. This would be across eastern North Dakota. There is a 2% tornado risk. There is some evidence that some storms could fire off the lake breezes up here near Lake Manitoba and Winnipeg and move southeast toward the northeastern corner of North Dakota and northwestern corner of Minnesota. Convective allowing models have shown that signal for a couple of days, but have definitely trended down a little bit with that target. You've also got a high plains mode across Montana that could develop, maybe some more tornadoes across central Saskatchewan. These bright colors down into the central Dakotas, I believe, are going to remain capped, and I think that a warm layer of air just above the ground may preclude the development of storms across that area. You can see the capping inversion right there, a little warm layer of air up a couple of kilometers above the ground. The photograph, though, does show wind shear that is supportive of a tornado, and different than the MCV, notice this big dry slot coming in aloft that's going to act to steepen the lapse rates, increase instability as well. So that could, but the issue is going to be lift as well, because there is a lot of cyclonic curvature to the upper levels. So that, in concert with a cap and not a ton of surface convergence, could result in less widespread convective initiation in that more favorable environment. See this anticyclonic curvature to the height contours? Usually that's associated with gentle sinking motion across the area. Meanwhile, ahead of these cyclonically curved height contours, ahead of an ejecting trough, you get a ton of lift. You also get aid with the lift from topography, where these low-level easterly winds getting forced up the terrain. So Saturday looks like more of a central Montana target might be ideal. And then on Sunday, that trough ejects in a zonal flow, and then it looks like it's going to excite the formation of a surface low off the northeastern corner of that ridge. Look at this ridge down here, shaped like an ellipse, a bit of an egg. You get a new trough that's coming in off the Pacific Northwest. That's going to lead to severe weather Tuesday, Wednesday across the Canadian prairies. Once again, Alberta into Saskatchewan. Looks like a very active pattern. But right here, right at the exit region of that jet, there is the potential of some pretty big severe weather into central Minnesota on Sunday. I am keeping a close eye on that for storm chase mode. Probably the northern edge of there, where the warm front, just on the northeastern edge of that surface low, that's where I think that there is a threat of a tornado into central Minnesota. You actually get a low-level jet as well, looking at 850 millibars, 1 kilometer above the ground. Definitely get a low-level jet that noses up into the nose of the instability up there. Wouldn't be surprised to get a tornado from that right on the nose of the low-level jet as well. But this is the first time that we've really seen a robust low-level jet like this in a long time, and you have a ton of Kate, 4,000 plus Kate, nosing into central Minnesota. Definitely could be a threat of a tornado with that, at least based on the NAM model. Photographs aren't incredibly favorable, showing all those westerlies, but a ton of big instability across Minnesota. 3 kilometer NAM shows that environment. Let's zoom in a little bit closer and see if this thing fires storms, realizing that the 3 kilometer NAM has not done a very good job with things this season. So we're drilling down a little bit closer to the forecast on Sunday. Thank you, everybody, for joining me. Hit that like button, notification bell, ring it. Let it rip if you like what you see. Looks like a lot of southwesterlies that are curving into that environment. Let's take a look at the surface low. There's the surface low up here into central Minnesota, and I think just ahead of this feature, we could certainly get a warm frontal zone. I'm live now. Talking to Mark. He's up. I actually asked him if I could use the footage before he woke up and just went live anyway, so hopefully he's not upset, but he definitely won't be. He's definitely happy to contribute to that analysis, but look at that low. That is the surface low in central Minnesota. There you can see it. There's got to be a warm front that extends to the northeast of that surface low that could have some more favorable wind shear across central Minnesota. South of that, though, I think it's going to be more windbag formation. But I think that somewhere along that boundary, just to the northeast of the surface low, that's where I think that there could be a threat of a tornado or two on, on Sunday. That's on Sunday. We're going to take a deeper dive on some of the other events as well. I also think there's going to be some more high plains insanity coming out. A big complex of storms that's going to move through this area on Saturday night. Right now, we're just looking at the very new 12Z 3-kilometer NAM. Let's see where it shows convection. This is at 0Z Sunday evening, so it definitely convects southwestern Manitoba across that zone. Complex of storms across the Minnesota Arrowhead. And if there can be some surface-based storms on the south side of that complex, then I think we're going to be talking about the potential of tornadoes. Looking at the low-level jet on the 3-kilometer NAM, 40 knots streaming up here. Minneapolis could be having a threat at least of some significant severe weather, but I think that the threat of tornadoes would be a little bit greater over the Minnesota Arrowhead during Sunday evening. We go back to the day before, Saturday evening. Here is the low-level jet across the eastern Dakotas that has prompted that 2% tornado risk. Eastern North Dakota into southern Manitoba. That's the low-level jet. But you look over at the HRRR, and it's a lot weaker. Look at that. Hardly any low-level wind shear available to these storms. Definitely a downward trend for Saturday severe weather across the Dakotas, at least according to the HRRR convective allowing models. No storms have developed. This is a forecast composite reflectivity. A couple of the other models were actually showing storms developing near Winnipeg and sliding southeast into the northeastern corner of North Dakota, northwest Minnesota. But as we're getting a little bit closer to the event, it does seem like that ridging is going to be a little bit more pronounced with the anticyclonically curved upper level flow leading to gentle sinking motion across this area. And that's why we don't get storms that develop within that relatively favorable kinematic and thermodynamic environment across the central Dakotas. We do get a complex of storms, though, that comes out of Montana, that develops first out here across central Montana, likely some large hail producers across central Montana into southern Alberta. This is on Saturday evening, and all of these are going to congeal into a complex of storms that moves all the way across eastern Montana, through eastern North Dakota, or all the way through the state of North Dakota. And that could disrupt the Sunday severe weather. So this is at 3Z. This is 10 p.m. Saturday night as those storms move through eastern North Dakota. Tail ender will probably have the greatest tail. Maybe this will be a derecho that forms off of the mountains of western Montana and then moves all the way across the Canadian prairies and across North Dakota. This is after midnight, Saturday night, 2-3 in the morning. Get some reinvigoration of the complex. And this complex is going to continue. Sunday morning, it starts to ramp up again over the eastern Dakotas. Probably a windbag rainmaker here. And this complex is going to progress all the way across northern Minnesota. And along its southern periphery, if we could get some surface-based storms along the outflow boundary from that complex, then I think that there could be some tornado threat that emerges across central Minnesota on Sunday. But there's your complex of storms. Looking at Sunday morning, arriving at the Red River right at about daybreak Sunday morning. There's the Red River. Hello? Okay. There's the complex of storms moving into eastern North Dakota. There's the dew points. Let's see the comparison between the HRRR and the 3-kilometer NAM. 3-kilometer NAM has some much better dew points up there. But let's look into Canada today. This is the NAM model. Today, Friday evening. These are dew points in excess of 20 degrees C across central Saskatchewan. I suspect that storms are going to develop just on the north side of this dry punch. There's a dry line coming in here with southwesterly winds to the south of it. You have southeasterly winds out ahead of this, wrapping that moisture around. This is this evening, Friday, so I think there's going to be tornadoes in central Saskatchewan. Basically, anytime you get this deep moisture up in Saskatchewan like this, you get a dry punch, you get southeasterly winds, you're at the very least going to get a lawnmower man type of a tornado into central Saskatchewan. But that looks quite favorable, and looking at the surface, you can see these surface winds, little subtle surface low as well across central Saskatchewan, and those easterly winds wrapping around the nose of that dry line, the nose of the dry punch, a belt of easterly winds all the way into east central Saskatchewan. That is where the threat of tornadoes is going to be greatest. We look at surface-based Cape out of central Saskatchewan. Look at that arc of Cape. Wow! Near 4,000 Cape, at least above 3,000 surface-based Cape. Saskatoon, you even have a wraparound of that instability axis. This is this evening into central Saskatchewan. Looking at the 0 to 1 kilometer EHI, you even have that belt of favorable low-level wind shear right into central Saskatchewan. It is going to be pretty far north up there, and your hodographs have a great shape, but a lot of times up in Canada, it doesn't really show the true magnitude of the low-level jet. You'll probably end up with like a 40-knot low-level jet in this massive curved hodograph up there, big tornadoes. You can see dry mid-level flow coming in, big Cape, steep mid-level lapse rates, steep low-level lapse rates, big moisture, directional shear, southwesterly low-level jet over top those easterlies. I would just be shocked if this doesn't cause tornadoes into Saskatchewan. And the environment expands. As you go through 10 o'clock, you could chase a lot later up in Canada also. Definitely initiate storms up there in central Saskatchewan. Very favorable hodographs, favorable shear profiles. So it is looking like the play was to chase Alberta yesterday and then chase Saskatchewan today. Would have got that tornado with Mark, participated in a lot of science, then would have been in central Saskatchewan today. Probably swung by some prairie rattlesnakes out there as well. But you could definitely see this large area of favorable surface-based instability and wind shear east central and southeastern Saskatchewan. That's your 0 to 1 kilometer EHI, 0 to 1 kilometer shear, in excess of 200 where the yellow areas are located. Warm front lifts pretty far north. You're probably going to get some tornadoes up here across the wide open terrain as well. A taiga up there, dense pine forests, major wilderness. Look at that. Even the regular resolution NAM fires that supercell up near Saskatoon, maybe even a little bit north, well into central Saskatchewan. The convective allowing models a lot of times don't extend their domain this far north. They do, but at least the ones that are tuned more toward the U.S. But boy, look at that storm. Develops just north of that dry punch. Saskatoon, probably going to get some tornadoes today. Very favorable wind shear. Mid-level jet ejects. There's your 40-knot jet streak nosing into central Saskatchewan. So one key to kind of beating the ridge riders in this anticyclonic curvature, the gentle subsidence that happens with that, is to go north. Get up as far north as you can up into Canada, way up into Saskatchewan, and eventually you're going to find surface-based storms that far north. That's your target today. Tornado potential pretty high up there. Even if I wanted to fly in there, my passport has expired, but here you've got the jet streak. That's your jet nose. Left exit region is going to come in over top there. That's going to provide the lift necessary to develop, to cause those storms to fire. Looking at some of your parameters, supercell composite, showing you exactly where those supercells are going to be. STP. Look at that. Boom. And I guarantee you that these parameters are going to be a lot higher than the NAM is showing. I usually just use the NAM to kind of see exactly where that environment is going to shape up. You've got dry air coming in the southwesterlies here. You've got a west to east dry line punch, storm fires in the wraparound to the north of that. Favorable window of low level wind shear too, 0 to 3, 0 to 1 kilometer shear. So that shows you where that's going to be. That would just be hanging in Saskatoon. Back in 2012, we were shooting season 1 of Tornado Chasers and we ran out of cash. We went broke up there in Saskatoon. I started crying up there that morning. Kind of some low endorphin content up there. But we were able to get a loan and continue operations for Tornado Chasers. But that was really the beginning of kind of the struggle period for the next 10, 15 years or so with TVN financially trying to scrap. But we actually are going to be releasing season 1 of Tornado Chasers on YouTube coming up here. I've got the first episode already downloaded, talking to Ken, and the plan is to get that uploaded on my YouTube platform so that everybody could see. We've got season 2 up there. Now we're going to put season 1 up. And of course, we are thinking about doing another season as well. But that season 1 did include our trip all the way up to Saskatoon. And we end up getting tornadoes up there. There was a supercell in 2012 that developed along a warm front north of Moose Jaw that produced a bunch of tornadoes. And we ended up getting on this QLCS line that had wedges just wrapped into it. Cones, all kinds of tornadoes. It's a very dynamic upper level system that was ejecting. But now I've got to get a rush on my passport. You go toward 10 p.m. and it shows that that environment expands and becomes even more favorable for tornadoes up in this environment. Nicely shaped hodograph. You want to look at the hodograph shapes more than the magnitudes when you're forecasting for Canada using the North American model. But this is big moisture for Canada. Trust me on that. That is big moisture up there. Classic elevated mix layer off the Northern Rockies. So I do think there's going to be more tornadoes up in Saskatchewan. Looking at the MCV setup. We'll use the same parameter to kind of see where the most favorable parameter spaces for tornadoes this afternoon ahead of the MCV. So by 21Z, it looks like southern Indiana could be in the action, and that slides into northern Kentucky. That's all caused by that accelerated low-level jet off to the south of it. Not very much of one being indicated by the NAM model. Let's take a look at the HRRR. Not a ton of low-level wind shear out there ahead of this relatively weak MCV event. But you do get some directional shear and abundance of moisture. Could get a ribbon of easterlies here across northern Kentucky. I do think that there could be a tornado or two from this. Maybe even similar to the one that we had a couple days ago when I was chasing in West Virginia. Southeastern Illinois could be the play, northern Kentucky, but you definitely get a ton of convection, and if you can carve out some favorable wind shear for a tornado or two, I wouldn't be surprised in this corridor to see a couple of tornadoes. And also we get a reinvigoration of storms down here into the mountains upstate South Carolina, into the mountains of western North Carolina as well. I'm going to be watching for potential landlocked storms that might even produce some life-threatening flash floods. Yeah, you can see all these storms at fire. They develop by mid-afternoon. You go back to 21Z. This is 4 p.m. Look at those storms developing over southeastern Missouri. Eastern Kentucky has an abundance of storms. But if you want to chase tornado potential, you got to work the MCV. It's the only place where you're going to get any storms that are organized low-level mesocyclones, and it looks like maybe into southern Illinois at about 4 p.m. A couple of those storms could go. But look at how spotty that parameter space looks. These are all just enhanced by outflow winds by the storm itself. Anytime you see those spotty, bright colors within these parameter fields like this, that's just outflow, northerly winds associated with those storms that are enhancing the environment just a little bit. It does look like southeastern Missouri tries to get a decent environment parameter space going. Then look at this into western Kentucky, but looks a little bit messy to me. And maybe around near Bowling Green into western Kentucky, you could get a more favorable environment that develops by this evening. But I think that that's just enhanced by northerly winds. If anything, just weak westerly winds. So I don't believe that there is too much of a threat of tornadoes today, but I do think that there's going to be possibly some flash flooding events, definitely some severe thunderstorm warnings. Here is the RAP analysis for Kentucky today, southern Illinois, all the way to Kentucky for the MCV target, where the Storm Prediction Center now has a slight risk based on this model guidance. This little cluster of storms could leave behind a bit of an outflow boundary. Look at that cape starting to build in. Summertime cape. And then you just get bubblers all over the place. Southerly winds. Westerly winds across eastern Kentucky. And back here where those winds shift to a more southerly direction, north central Kentucky, maybe you can get a mesoscale accident or two out there and get a couple of tornado events. But I think this is going to be more of a flash flooding event across central Kentucky, northern Kentucky, southern Indiana, back into southern Illinois. Air mass thunderstorms. MCV is just not organized enough to really generate much in the way of big problems up there, but I think we're going to get occasional flash flood warnings down in the southeastern U.S., occasional severe thunderstorm warnings today, and then more widespread convection during the day on Saturday across the southeastern U.S., upstate South Carolina into the Carolina Piedmont. More bands of thunderstorms coming off the southern Appalachians, some of which could train over the same areas and produce some excessive rainfall. So thank you everybody for tuning into this weather report. Thank you for tuning in to the recap on yesterday's tornado that touched down just to the northeast of Bergen. There you can see that storm on radar. We discussed that this is the donut hole region of that tornado. You can even see a little bounded weak echo region within that. Definitely the new wall cloud that was indicated by Mark was right near that inflow notch. That was the next tornado that was about to touch down, which I think that he observed at least a weak tornado or two. Here you can see that photo at maturity. This is right at about the same time as that radar image. The tornado is inside, embedded within this rain, and the rain sheath is the donut. And then here is the new wall cloud that shows that new circulation that's developing in the new inflow notch. You can actually see the notch right here. This is the forward flank gust front. This is the bulging out RFD, and that notch, that's also where we want to aim the rockets when we launch into there. Like 2019 with the Linwood tornado, we're trying to just hammer that notch with rockets and trackable miniaturized sensors. But you can definitely see the new cycle with that wall cloud off to the east. I do want to recap that damage path one more time, just in case some people joined late. Here is the drone video that was captured by Mark, showing you the softwoods that are flattened. Typically, anytime you see these mass flattened softwood forests like this, even hardwoods, of course, as well, you will usually get an EF2 tornado. So I'd be shocked if this didn't get an EF2 tornado based on the damage that I've seen. Here is the damage path that Mark laid out, showing you this hook to the right. When this happens, the tornado's roping out, and then it starts to get the northerly rear flank downdraft surge, cold air wrapping around the backside, and that will lead to a roping out tornado to bulge out and then turn off to the south until it dissipates. And we do have some pictures that support this too. Here is the video also from Mark, showing you, I think, as that tornado is moving off to the south. You can almost see the cold air, the dome of cold air. It's more dense. Cold air is more dense, so it tends to go slide in below the warmer air. And you can see that cold pool dome moving from north to south, causing that tornado to develop that curved look. And it's stretching along the leading edge of the cold pool. That's the vortex as it's roping out. And that was likely the terminus of that tornado damage path. Very accurately and precisely identified by Mark. Chase and Spin on Twitter and YouTube. So thank you everybody for tuning in to this live weather report. If you enjoy these in-depth analyses and in-depth forecast discussions, definitely hit that notification bell, sign up, subscribe. Thank you, Facebook, as well, even though I'm getting hammered on there by the algorithm because of all those fake copyrights that are coming in. Just need to get a real person at Facebook that I could talk to, and we could definitely alleviate that. Thank you to Brian for constantly innovating my graphics on here. Tickers, Team Dominator logos. We've got all different kinds of things that we're rolling out. Custom radar as well coming up here just in time for hurricane season. Thank you, everybody, for joining me today for this weather report. I'm going to swing by the Grease Rabbit and check in on Dominator 4, see how that's doing in the face of parts shortages. Once that's fixed as well, I'm excited to get the Dominator 4 back in operation. Thank you, everybody, for tuning into this weather report. Never stop chasing.